In the previous session, we saw some standard integrals. Now let's solve some problems. First one is integral of 3e to the power of x minus 4 by x dx. Okay, so based on what we have learned, can we find the integral of this? One thing that we have to know is that the integral of sum of two functions or difference of two functions is equal to the sum of term-wise integrals. So basically, we have a sum or difference of functions under the integral. We can split them into two separate integrals. So based on this, and one of the standard integrals was what? A scalar multiple of a function. So that scalar can be taken outside the integral. So we have 3 times, 3 we have taken it out because it's a constant, times the integral of e to the power of dx. Minus 4 is a constant, so we take it out. So 4 times the integral 1 by x dx. And we have seen this as standard integrals, integral of e to the power of x and of 1 by x. So 3 times integral of e to the power of x dx is e to the power of x plus the constant of integration for this integral minus 4 times the integral of 1 by x dx, that is natural log of x, plus c2, the constant of integration for this integral. This again we can simplify it, saying 3 times e to the power of x minus 4 times the natural log of absolute value of x plus c, where c is equal to c1 plus c2. Because c1 and c2 are constants, we just add them up. And don't forget the absolute value. So that was our first problem. Let's look at the second one. Again, we have integral 3x square minus 4x plus 1, the whole thing divided by root x dx. So here, what do? We split this into 3 fractions. So we get, and we take the constants out. So 3 times the integral of x square by root x dx minus 4 times the integral of x by root x dx plus 1 by root x dx. Now, let's simplify these integrals. So we are having here x square and here we have root x, which we can treat it as 1 by 2, x to the power of 1 by 2. So when we take it up, it becomes 2 minus 1 by 2 dx minus 4 times, again here also x to the power of 1 minus 1 by 2 dx plus integral of x to the power of minus 1 by 2 dx. Simplified further, 2 minus half is 3 by 2. So 3 times the integral of x to the power of 3 by 2 dx minus 4 times the integral of x to the power of half dx plus integral of x to the power of minus 1 by 2 dx. Now, which integral should we use? Which standard integral? Remember, integral of x to the power of n dx. So we apply that. When we apply that, we get 3 times x to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1 minus 4 times x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 plus again x to the power of minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. And now we start simplifying it. So 3 times x to the power of 5 by 2 by 5 by 2 minus 4 times x to the power of 3 by 2 by 3 by 2 plus x to the power of 1 by 2 by 1 by 2 plus c. Simplify it again. So here the 2 that is there at the bottom, they all go to the top. So 3 times 2, 6x to the power of 5 by 2 by 5 minus 8x 3 by 2 by 3 plus 2x to the power of 1 by 2 plus c. So that is the integral of this function. Okay, third one. Integral of cos x by 2 minus sin x by 2 the whole square dx. Again, let's open it up. Take care of the square. We have integral of cos square x by 2 minus 2 times cos x by 2 times sin x by 2 plus sin square x by 2 dx. This cos square x plus sin square x, rather cos square x by 2 plus sin square x by 2 is 1. So 1 minus 2 times sin x by 2 times cos x by 2. That is equal to 2 times sin x dx. That is actually 2 times sine 2x by 2. So 2 cancels out and we are left with 2 times sine x. Again we split it. We get integral of 1 dx minus 2 times integral sine x dx. Integral of 1 dx is x. Remember, when we differentiate x, it becomes 1 minus 2 times, we know the integral of sine x is minus cos x plus c. And finally, we get x plus 2 times cos x plus c. So that is the integral of this function. Integral of cos 3x divided by cos cube x dx. Okay, now here we need to know the identity. What is cos 3x equal to? So integral of 4 cos cube x minus 3 cos x divided by cos cube x dx. Now, of course, if we don't remember this identity, we are stuck. Okay, now again we split it into two fractions. So integral of 4 cos cube x by cos cube x dx minus integral of 3 cos x by cos cube x dx. And now 4 dx, because cos cube x cancel out. So we have integral of 4 dx minus integral of cos x, and one of the cos x in the denominator disappears. So we have 3 by cos square x dx. We know the integral of 4 dx, but we carry it one more step and take it further. Minus integral of 3, 1 by cos square x is sec square x dx. So finally we have integral of 4 dx is 4x minus integral of sec square x is tan x. So 3 tan x plus c. Now why did I carry integral of 4 dx as it is? Because I wanted to avoid creating one more constant of integration, say c1, and then coming out with c2 and then adding up and writing it as c. Okay, so that was just a taste of what we can do using standard integrals and integral of sum and differences of functions. Now, in the next session, we will look at something much more interesting with respect to standard integrals. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.